What's going on YouTube? And here's another video for you from your favorite YouTuber, Coach Carr. This one is on trig ratios. I had to redo it because for some reason the sound got messed up. But this is page 15 and 16 in your notes. Alright, so just like with any lesson, we have a learning target and success criteria. Now, the learning target is to define trig ratios and solve problems involving right triangles. The success criteria is I will be successful when I can set up sine, cosine, and tangent problems. Alright, so right now we are looking at page 15, and on this page what we're trying to do is to find the missing sides first, and the way that I like to remember this and remember which sides go with which is with SOHCAHTOA. Now, you don't even need to actually remember this because you actually get a reference sheet when you take the EOC that has the sine, cosine, and tangent, but this is just the way I've always been taught to remember it. So if you notice the symbol for each of these, that symbol represents an angle. So each of these has to have at least 1 degree in there, some kind of angle that is not the 90-degree angle that you already have in your right triangles. So for sine, you have the O and the H. The O represents opposite, and the H represents the hypotenuse. So opposite over hypotenuse. Cosine goes with A over H. The A stands for adjacent, and H stands for hypotenuse. And for tangent, you have the O and the A. O stands for opposite over adjacent. Now, to find the missing angles, the way that you do that is through an inverse function. So you're using the inverse of sine, cosine, and tangent. So just like the one that you see here for sine, to find the angle, you do the inverse of sine, and you still have opposite over hypotenuse. Cosine is still adjacent over hypotenuse. And tangent is still opposite over adjacent. So we will show you in a little bit how to actually use this. Okay, so right now we're looking at number 1 on this same page. It wants us to set up the sine of A, cosine of A, tangent of A, and the sine of B, cosine of B, and tangent of B. And so first let's do the sine of A, cosine of A, and there was a little bit of a misprint on here. The tangent made it on the next page, so instead of making it so we have to switch from page to page, just write the tangent of A right there. So when they say the sine of A, they're talking about angle A. So that is this angle right here. What we want to do first is label our opposite, adjacent, and hypotenuse. The one that I always label first is the hypotenuse because it's the easiest one to find. And the reason I say it's the easiest is because it's always across from the right angle. So this would be the hypotenuse. Now the adjacent and the opposite can be different depending on which angle you're looking at. So since I'm looking at angle A, the adjacent to it would be this side here. So adjacent tells us something that's right next to it. So the side that is next to this angle that's not the hypotenuse would be right here. And then opposite is going to be across from the angle. So this side is the opposite of angle A. So if I were to do this, sine is opposite over hypotenuse. So my opposite would be 1. My hypotenuse would be C. So I would have 1 over C. Cosine of A, cosine is adjacent over hypotenuse, so my adjacent is 2. and my hypotenuse is C. And then last for this angle A1 is tangent. Tangent is opposite over adjacent, so opposite is 1, adjacent is 2, so I have 1 over 2. Now let's look at the sine of B, cosine of B, and tangent of B. And again, for this one, I'm going to write my tangent of B here so we don't have to go to the next page. If I'm looking at angle B, I'm looking at this angle here. Now, the hypotenuse didn't change because that's always across from the right angle. What is going to change when I'm looking at angle B, though, is the adjacent and the opposite. Because remember, adjacent is touching the side, so the one right next to it, that's not the hypotenuse. So this would be my adjacent side, and across from it would be my opposite side. So now when I do it, sine of B, sine is opposite over hypotenuse, so the opposite for this one is 2. The hypotenuse is C. For cosine of B, you have adjacent over hypotenuse. Adjacent is 1. Hypotenuse is C. And then tangent of B, tangent is opposite over adjacent, so I would have 2 over 1. So the one thing that hopefully you notice is, like when I have the sine of A, it's the same thing as the cosine of B. Cosine of A is like the same thing as sine of B. And the tangents are flipped over, and you have like the inverse of them. Okay, so right now we're looking at page 16, number 4. So we are going to end up using trig to solve these ones. And what we want to do first is label each of the sides. So label which ones are hypotenuse, label which ones are opposite, and which ones are adjacent. So you have to look at which one you actually have an angle for. And in this case, the one we have an angle for is this one right here. So based off of this angle, I'm going to label everything. Now, I earlier said I like to label the hypotenuse first because it's the easiest to find. And the reason it's the easiest, it's always across from the right angle. So the hypotenuse, again, is our longest side. So this is our hypotenuse. Now, adjacent is going to be the other side that's next to this angle that's not the hypotenuse. So this side would have to be my adjacent. And then across from this angle would be the opposite. So now I have labeled everything. Now we can start finding the stuff that they want us to do. So they want us to find the side or the line segment AB. So AB is the hypotenuse. So I'm going to be trying to find the hypotenuse. In order to do that, I know I'm going to be searching for this. I also have to see which one I also have a value for, an actual value for one of the sides. And the one that has that is AC, which is our adjacent. So the only one that uses both the adjacent and the hypotenuse is cosine. So the way I set it up, cosine of the angle 32 equals, and remember it's adjacent over hypotenuse, so the adjacent is 10, and the hypotenuse is what I'm trying to find. So since I don't know what it is yet, I'm going to label it as x. So next step now would be to multiply both sides by x, because I'm trying to get rid of this fraction here and trying to get x by itself. So now you have x cosine 32 equals 10. Now again, I'm trying to get cosine by itself, so now I'm going to divide the cosine of 32 to both sides. When I do that, I get now x equals 10 over the cosine of 32. When I do this in my calculator, what I end up getting is that x equals 11.79178. So another way when you that you can know to like save some steps, if x is in the denominator over here, basically I know that these are going to flip. So x would just replace the cosine of 32, and the cosine of 32 would go under there. If you remember that, that's a little shortcut for you. Alright, so now we're looking at the next part, which is trying to find the line segment CB. So CB is the opposite. So I'm trying to find the opposite now. I want to also use a side that I already have. That would be my adjacent. So the only one that uses opposite and adjacent is tangent. So I'm going to be using for this one tangent still of 32 degrees because we're using that same angle. And that's going to equal, it goes opposite over adjacent. So opposite, we don't know yet. That's what we're trying to find. So I'm going to put x, and the adjacent would be 10. So what I would want to do now is multiply each side by 10. So that we get rid of the fraction. So now you have 10 tangent of 32 equals x. That you can do in the calculator. When I do that, I get 6.24869 equals x. Okay, so the last problem that I am going to be doing in this video is number 5 on this same page. So the first thing they want us to find is the line segment AC. So when you already have the value of two sides and you're trying to find the last side in a right triangle, you're going to want to use Pythagorean theorem. If you don't remember Pythagorean theorem, that's the a squared plus b squared equals c squared. Now, a and b can be interchangeable, but c does matter. C has to be your longest side. And the longest side is always going to be across from the right angle. So I know C is going to end up being the 15 squared. And then, like I said, A or B can be interchangeable. So instead of A, I'm going to do 13 squared. So I'm going to be trying to solve for B in the way that I set it up. So now I want to actually square them. 13 squared is 169 plus b squared equals 225. I'm trying to get b by itself, so the next thing I would want to do is subtract 169 from both sides. And when I do that, I'm going to get b squared equals 56. And the next step now is I want to get rid of the square. And the way that you do that is with a square root. So b equals the square root of 56. Alright, so now that we have the square root of 56, let's put it into the simplified radical form. So the way we do that, if you remember, we find our multiples of the number, in this case 56. So I'm going to do 14 times 4. Now 14 can be broken down to 7 times 2, and 4 can be broken down to 2 times 2. So remember that you want to look for your pairs. So the pair that I have would be the 2's. So whatever number you have of the pair, that's what goes outside the radical. Whatever's left over stays inside the radical. So we had a 7 and a 2 left over, so 7 times 2 is 14. So the way that I would want you to keep your answer is in this simplified radical form, like you see right there. Alright, so the next thing that we want to do is find angle A. So what we're trying to do is find this angle here. In order to find an angle, if you remember from the page before, we're going to end up having to do an inverse function. Now, with an inverse function, you still have to label each of the sides like you did on the problem before. So we have our hypotenuse is across from the right angle. So this would be my hypotenuse. Now the adjacent side is going to be the one that's touching that angle, but not the hypotenuse. So this side's the adjacent. And then across is the opposite. So the ones that we have values at is at the opposite and the hypotenuse. The only one that uses opposite and hypotenuse is sine. So I want to do the inverse function of sine times opposite over hypotenuse. So 13 over 15. When I do that, I would get the answer of 60.07356. And let's say if I round it to the nearest whole number, that means that it would be roughly 60 degrees. Thank you so much for watching. This is the end of the video. Make sure you do exit slip number 9. And besides that, make sure you like, subscribe, ring that bell, do all that good stuff.